All right, guys, really important video today. Basics of hypothesis testing. We did the whole ha stuff the other day, so you're familiar with null and alternative. And I'm going to kind of review that a little bit again, but take a couple steps further. So hang in there, get good notes, really watch this carefully. Examples of hypotheses that can be tested. First one says law. Republicans claim in the lawsuit that New Jersey County Clerk did not use the required method of random selection when he chose the Democratic candidate to be first on the ballot in 40 out of 41 elections. So what they're trying to test there is, did that have an outcome, did it have an influence on the outcome of the election because they put the Democrat name first on 40 out of 41 elections. Genetics. The Genetics Institute claims that XSort method allows couples to increase their probability of having a baby girl, and sample evidence consists of 879 among 945 treated with the XSort method had girls. So we're going to see, does that mean their method was effective? It sure looks like it. Health. It is often claimed that the mean body temperature is 98.6. However, we have a sample in our data set in the back of the book, which includes a sample of 106 people, and their mean temperatures was 98.2. So we want to test, is it really 98.6 or is it less? Business. A newspaper cites a pricegrabber.com survey of 1,600 people and claims the majority of consumers have heard of Kindle as an ebook reader. So that's important with how many books they want to sell as far as like hard copies. Quality control. When new equipment is used to manufacture aircraft parts, the new parts are better than the variation in the errors is reduced to the readings are more consistent. So we're trying to figure out, are the new ones really more consistent than the old ones? So those are just examples of things we can use to test hypotheses on, and now we're going to go to the procedure of how you do that. Okay, steps. Number one, identify the null and alternative. That's your ho-ha. Identify them, write them as like you're supposed to with your ho-ha. Number two, calculate the test stat. We're going to do that at the end of the lesson, in this end of this video. Number three, choose the sampling distribution that is relevant. Okay, are we looking at the normal curve, the t distribution, the chi-square? Which one are we looking at? You got to choose the right one. Either find the p or critical values. We're going to find the p-value. That's going to be our method of choice. State the conclusion in simple terms. That's the most important thing we do. You've got to state the conclusion. You fail to reject the null or reject the null, and what that means when you do that. Okay, what is a claim? Just a few examples here. A claim might be the mean temperature is less than 98.6. We did that a minute ago. Notice all these claims have to do with the population. The proportion is greater than 0.5 that the XSort method works. Standard deviation is 15 for IQ scores for college students. Who knows? So those are just examples of what claims look like. So when we use the word claim, that's what you're kind of looking for. All right, testing the claim here. Assume that 100 babies are born to 100 couples treated with the XSort method of gender selection that is claimed to make girls more likely. If 58 out of the 100 babies are girls, test the claim that with that method, the proportion, that's the P, of girls is greater than the proportion of 0.5 that occurs without any treatment. So if I were going to do my ho-ha, my claim would be that. My claim is, that's my ha, P is greater than 0.5. My ho would be P equals 0.5. Now, here's the deal. Is 58 girls high enough to justify the conclusion that the method is effective? Well, we found our P, and our P value is 0.0548, which means the probability of that happening just by chance is 0.0548, which is still high enough. It's greater than 0.05 and definitely greater than 0.01. So we're going to say the probability of getting more girls is not increased that much with the method because it's not statistically significant. Here's a good sentence at the bottom. Because the probability is not less than 0.05, we will conclude that it's easy to get 58 girls in 100 births by random chance. So we cannot justify the conclusion that the method is effective. And that's how we're going to roll this whole section we're doing for a couple of weeks, is doing that kind of thing right there. All right, this is huge. Rare event rule. This is why we do what we do. And it says this: if, under a given assumption, the probability of a particular observed event is extremely small, we conclude that the assumption is probably not correct. Okay, the keyword there's a probability and a probably in there. All right, so if we get a real small probability, we're going to assume the assumption is not correct, which is a big deal. So a couple examples here on the bottom. Example, in testing the XSort gender selection, it is supposed to make girls more likely than boys. The result of 52 in 100 is greater than 50, but 52 could easily occur by chance, so it's not sufficient evidence to conclude that it's effective. However, Look at this one. What if we got 95 girls out of 100? That is much greater than 50%. I mean, much greater. It's so extreme. You could not easily say that would just happen by chance. So there is sufficient evidence. And of course, we're going to put some numbers with that, but that's the general logic of where we're going. The p-value method, which is the method we're going to choose. Number one, we're going to identify the claim and put it in symbolic form, which basically means number two, we write it like ho-ha. All right, number three, and when I say symbolic form, that means is it a mu, is it a p, is it a baby sigma, what kind of measure is it? Number three, select the significance level, usually one of those two. We're going to use 0.05 the most, but occasionally we may use a 0.01. Number four, identify the test stat that is relevant, determine its sampling distribution. Are we using normal? Are we using t? Are we using chi-square? Important. Test out, we're going to use technology for that a lot. Number five, find the p-value and draw a graph. We are going to draw graphs and show the p-value. That's going to be important. And then we're going to do our conclusions. Number six, we're going to reject HO, reject the null if the p-value is less than one of these two numbers up here. And we're going to fail to reject it if it's more than one of those. And then we're going to state our findings. That's going to be number seven, so important. We're going to restate our findings using simple, non-technical stat terms and address the original claim. All right, first part says write in ho-ha form. It says claim 30% of adults eat out twice a week. A recent Gallup survey of 1126 random selected adults show that 33% eat out twice a week. So what we do is this. Those are proportions. So my ho, I would say my proportion would equal 30% or 0.30. My ha, I would say would be more than 0.30. Remember, it's always population, and your null hypothesis always has equals. And the sentence at the bottom is good. Using only the rare event, should say event rule. Make a subjective estimate to determine whether the result was likely, then state a conclusion about the original claim. I would say this. I'm just being subjective now. I haven't run any tests or anything, but 33% is not that much bigger than 30 for one sample. So I'm assuming that's probably within a couple of standard deviations away. So I'm going to say because of that fact, I would fail. I'm not convinced that that's enough info to say that that number right here is not true, that it is still 30%. So I would say I would fail to reject the null. I would fail to reject that fact. So there's strong evidence to show that the number is still at 30%. Okay, find the value of the test statistic. This is the last part of what we're going to get done today in this video and also in your assignment tomorrow. So 75% of adults believe it's important to be involved in their child's school. I wish it was more than that. A Gallup poll of 2021 recently found that adults found an 89%, that's better, believe it should be important to be involved in their child's school. So what would be the test stat? Now we're going to use technology. I did StatCrunch. I'm going to tell you what I did. If you go to StatCrunch and you go to stat, and you'll see something that says proportion stats. Now I picked proportion because this is percentages. I did one sample with summary, and I just punched stuff in, and I got 10.35. I don't know, that's kind of random right there, but if you wanted to try and get that number looking at your StatCrunch while you're watching this video, or stop it or whatever, maybe you could figure it out. And I will show it to you in class tomorrow anyway, but just in case, that's what we're going to do. All right, and if you did want to work these test statistics out by hand, this is what you're going to go through right here. And it's okay to do it that way. If you got a calculator, you're fine. If you're doing a proportion, here you go. Only condition is, you're going to use a normal z, and it must be normal, and those two things must be true, which are going to be true. The mu, if you're going to find mu, you're going to do t if that's not known like we have been, and it's normal. Or if you do know, if you don't know. If you do know baby sigma, and you know n is bigger than 30, you're also going to do the t. If you're looking for mu, you can use normal if you do know baby sigma and it's normal, or if it's known and it's bigger than 30, because bigger than 30 means it is normally distributed. And lastly, if it's a standard deviation problem, you're going to use chi-square. Strictly must be normal, and there's your test stat right there. So if you want to do it by hand, you can do that. I don't recommend it. We're going to go technology. I think once you see the technology, that's how you'll want to go, but we did want to show that to you. So see you tomorrow.